Ever wanted to know how to go beyond the EWM standard? In this series of videos, we'll show you the tools and tricks to enhance your EWM.
Welcome back, folks, and welcome to another video of the series Enhance SAP EWM. And in this video, it's really gonna become tough. We are handling the warehouse order creation rules, and this is one of the more complex topics in SAP EWM. So this is a video for the more experienced guys among you, and I can also promise you, if you are not interested in this topic specifically, it's gonna become very boring for you. Yeah, it's pure technical stuff, and the intention of this video is really to teach something, to transfer knowledge, and this is not about entertainment. So it's really a lot of technical content. So I structured this video in a way that we have a rough overview of the EWM standard warehouse order creation rules, so that just to catch up for the ones who did not tackle this within the last months, just to get a quick overview, and then we make what I call body hike. So we are making a quick tour throughout all those bodies which are being used in the warehouse order creation rule world. So this hike will have at the end 15 stops, where we stop at, I think, around 11 to 12 different bodies. We will always look at the spot where the body is called, the exact spot in the coding, but I will also show you the stack during runtime, which is very important from my perspective, so you know in which context the bodies are being called and what happened just before. And I will also show you the interface, so the import-export parameters of the interface method, so you know, based on this, you can understand what you can do with the given body. Yeah? So we start with the first step here, the rough overview. What are the warehouse order creation rules? I will not go into detail here, just very rough overview. I made another video, I will put a link in the description, where I explain the standard on a basic, easy to understandable a level which is easy to understand. So if we consider these 10 steps here, what we need at the beginning for the warehouse order creation rule is always a warehouse task, and this can be created during wave release or during warehouse task creation via PIDO transaction or any other option that you have in mind. We need some way of warehouse task creation to get started. Now I went one slide ahead. So we have the task, and then they are grouped by queue and by activity area, and then we apply with the warehouse order creation rule search. That's what you see in customizing based on queue and activity area. We determine warehouse order creation rules which are to be applied, and at the very beginning we apply a filter on item levels, so we kick out warehouse tasks which do not fulfill specific requirements. Then before we apply the filters on the level of the consolidation group, so the subtotals, we actually do a sorting, which is 0.6 here. That's the inbound sorting for the warehouse order creation rules. And once we have done the filters on the subtotals, we apply the limits. So that's the totals of specific parameters on the warehouse order level, like the maximum weight and so on. And then we try to create like play and pick HUs. And in this context, we are again sorting. I didn't mention this here with another number, but we are sorting here also. And we are also sorting at the very end again within the warehouse order. So to influence travel paths and all this stuff. That should be it for the overview. You will find for almost all those points customizing notes in the reference IMG here, and this is where you do the respective settings. In this video, we will not look into the standard that much, but we will answer the question about how we can actually enhance what the standard offers. And for this purpose, we do our body hike, and we are traveling throughout 15 stops and more or less exploring function module SCWM WHO_create. That's where all the magic is happening. The enhancement spot where you'll find all the bodies is mentioned over here. Oh, sorry, there's a typo. The C is missing, but you see the correct wording over here. And you will find all those bodies, which we will look into detail now throughout the next slides. So this is the first one, and this is also how the following slides will look like. Yeah, on the upper right, you will find the name of the body. You will find a bullet point about what you can do here. Then on the upper left, you will find the parameters of the interface method. And then you will always see a screenshot with the exact spot in the coding, the given object, and you will always see the stack. And that's what I mentioned before. This is what I thought would be helpful for you to locate this also later in your system. So first stop, override consolidation groups. I will not spell the name of each body now, you see it over here. So we just grab the warehouse task and we could override the consolidation group which the warehouse task got from the warehouse request item. Pretty straightforward. Yeah, just changing the data in this parameter CTTO, and that's it. Here we are importing LTTO. This internal table has the field DSTGRP, and this is what you're going to change in this implementation of this body. Next one, we need to just spend a couple of minutes for each body, otherwise this video will become very, very long. So XWHO_create, this is what you're going to implement if you want to do 100% custom logic. Having said this, this also means in case this is implemented, then EWM will skip all the standard logic and everything that you see on the following slides will not be touched. So if you implement this one, you basically assume that you will do everything in your coding. And I thought about this could be a point where we might in the future just offer an API and let our warehouse order creation rule run somewhere somewhere in the cloud based on the sophisticated algorithm, and which gives us a better result than EWM does. And that was just an idea. Good, yeah. You see the spot, and you see the tables that we can change here. So you see it's not only the warehouse orders, but you also import here again the HUs, and so the packing is also happening within the implementation of this body. Sorry, I cut the stack, so I promised too much before, but on the following bodies you will see the stack. Here it is. Okay. And you also see that if this body is used here, we will just return, and everything else will not be relevant. Everything else from the standard. Next one, filters at item level. Additional filters. So you have filters in the standard, but if these filters in the standard are not sufficient, you can just apply your own filters, and that's also pretty straightforward. You see in the interface, everything that should be filtered out based on Z logic is to be written into this internal table TO failed over here. Next one is the inbound sorting. As I said, that's only happening after the filter on item level, which makes kind of sense because if we apply a filter on item level, it's not relevant how the sorting of the task is, because this is going to be applied to every task. So it doesn't matter that we are sorting only after the step, although this is called inbound sorting. But it is happening over here. So the new sorting would be in the CTTO again over here. Here's a spot for the body. And you will see that the same body we will call 2 more times. One more time during packing, and one more time at the final warehouse order closure, where we sort within the warehouse order. Now here, this sorting is an impact on how the warehouse orders are created. So which tasks are grouped into one order. And the sorting at the very end, that has an impact on how the picker will later travel through the warehouse, because we know already which tasks are in one order, and then we want to influence the sequence in which they are being processed. Number 5, filters on subtotal levels. So subtotal here means the level of consolidation group, and you should know the concept from the standard for these kind of filters. So we are accumulating, for example, the weight or the volume for all tasks from one consolidation group and apply filters to this cumulated value. And here we can just apply our own filter logic here, and if a consolidation group does not pass a filter, we just write it in this variable here, CV failed. Did not pass custom specific filters, and then we just continue here with the loop. Next one is the limit, and the limit is also one of the easy to understand features of the warehouse order creation rules. Limit like a maximum weight of 10 kilograms per warehouse order, and the standard has like around 15 different limits, and if we want to apply our own limit, just write it into the implementation of this body, and here you can you can change. I'm not 100% sure. I think we change the standard limits here. We do not do our own stuff. We change the standard limits and write it into this table here. And so that means the standard coding, applying the standard customizing limits, that will happen after this body. So the limits are fixed in the warehouse order creation rule via standard customizing, and what we do here is change the values from the standard customizing. And we do not add anything, we change the values here, and then once this body is passed here, then the standard is being applied with the changed values. And that's how it works. So here that should look pretty familiar to you. It looks like the standard customizing with the limit values, and here you change based on your needs, and this is what we import in the body, and then change and export the updated values. Okay, now we already arrived at the packing proposals. So in the context of the warehouse order creation rules, we have the option to create planned pick HUs, and the standard determines the packaging material for those pick HUs via condition technique based on condition records. And if this is not sufficient, so you cannot determine, or you do not want to determine based on condition records, you can here apply your own logic to determine packaging materials and write those here in the table of allowed packaging materials and return it from the body. If you're using this one, then we are not checking the standard condition technique. The next one is PMAT check. That basically assumes we did not apply the body that I mentioned before, but rather use the standard determination logic based on the condition records. And whatever we found based on this logic, we now manipulate. So let's say we found 12 different packaging materials, and this result we can now sort or remove packaging materials based on some logic, and still have an impact about on what is being used here. Again, the stack, and again the spot over here. You see that we could even manipulate the characteristics of the packaging material, like the max weight and capacity values of what we found. So as I mentioned before, we are again sorting now, and the next, I think the next three bodies we will only call in case, we will only be able to call in case our packaging profile has a pack mode A or B. Now pack mode C is its own body. We have simple complex algorithm, and the pack mode C is just a separate body we will see later, but A and B is are the options that will call those next three bodies, and option C is like a completely coupled Z logic that will not even call the other bodies because it's skipping all the standard logic. So assume we have A or B, and we have a sorting rule over here in this field in customizing. Only then we are calling this body, and we are importing here the WTs to be sorted, and we are exporting the new sorting from the interface method. So here you can inference which tasks are ending up in one pick HU later, in one planned pick HU. And here's a spot where this is happening. Actually, body should even be called if no sort is maintained. So not 100% sure whether what I mentioned over here, whether this is correct. Don't nail me on this one. I think I found a spot in the coding where this field is checked. Right now I'm not 100% sure. Need to do your own research here. Next one, WHO pack check. So here you see again these two pack modes, A and B. Only for those two the body is relevant, same as the one before. And this body is simply looping over the task, and you can say this one is going into this HU and this one is not. Pretty easy. You see which tasks are already assigned to the HU. We have the current warehouse task, which we are looping over, and here we can say it should be included or not. Pretty easy. It's being called. And we are in the method, in the subroutine advanced packing, where a lot of stuff is happening here. WHO packed in. Next one, stop 11, and here we check the dimensions. So 2 times, one time for HU warehouse task and 1 time for product warehouse task. I'm not sure when somebody would actually use the warehouse order creation rule with the packing profile for HU warehouse task, but it is here in the coding. More relevant probably is the spot for the product warehouse task. And this body will only be called in case you check this flag here in customizing, so that the length, width and height are actually being checked against the dimensions of the packaging material. And the standard check will just check against the max values, and here you can just influence the check. So if you want to say, for this packaging material, want to reduce by 15% tolerance, I don't know. And here's the spot where we call it. Stop number 12. We can skip distribution group. So we can say specific consolidation group should not be assigned to a Pikachu, and then we just skip it. And this will only be applicable in case we have a max value here, which is and it will only be applicable in case we have more than one consolidation group within our bucket of task. Otherwise it makes no sense. Here, so the only thing we do is need to set set the skip variable. Number 13, that is what I mentioned before. This body, WHO packing, will only be called in case we set the pack mode to C, and this is just like 100% custom Pikachu creation logic. You import everything you need here, packaging materials and warehouse task and limits and all this stuff, and we change then the task and the ones which are packed, and we also import and change the Pikachus over here. And the spot, the calling is here, subroutine HU determination, and here you see when the pack mode is set to C, only then we run into the body. Almost done. Packing is done. So finally, two more bodies. Number one is the one where we can override the warehouse process type of the warehouse order itself. Just write it into this variable here. This is the header warehouse process type for the warehouse order. Do not be confused, at least in my system version. Here the comment in the coding is wrong. It says WHO sort, but here we are not calling the sort body, but the HDR process type body. Last but not least, I mentioned this already. Again, we are calling the sort body, and this time within the warehouse order. So the warehouse orders are actually completed here, and now we want to have an impact that manipulate the travel path. So the sorting within the warehouse order, and we actually influencing which tasks are processed in which sequence within the warehouse order. So if you want to minimize the travel path in the warehouse, just as a typical example. We are changing CTTO, new sorting, we saw this already, and here is the spot subroutine WHTO sort, and at the very end of the subroutine create end. That's it. That was a long journey, a long hike. You saw lots of bodies, and that is what I wanted to show you with this video. The main lesson, I think, is that you can actually enhance everything here. So you can every item, every point that you see in the customizing, you can write your own custom logic, and you can make a function which is already complex, you can make it even more complex. And that's also my second main takeaway. Apart from the fact that everything can be enhanced over here, just keep in mind with every enhancement that you implement, you make this machine a bit more complex and a bit more reluctant to robustness. So you make it a bit more unstable and a bit less robust. So just keep in mind, probably in the future somebody else needs to understand your changes and need to maintain it, and that's most probably not yourself. That's another main takeaway from this session. Apart from this, that should be it for this video. You would really motivate me to proceed with this channel in case you give me a like, or just leave a comment with your thoughts, with what you think about the video, and also feel free to give me your ideas, suggestions for additional videos. And of course, if you found a mistake, I'm pretty sure I made some mistakes, gave some wrong or misleading information, yeah, and I'm also thankful if you point this out and leave me a comment so I can also learn from this. And that should be it. Now don't forget to subscribe to the channel so we'll see us with the next video. Thanks and goodbye.